drive technology, the core of the storage environment, was not designed to accommodate today's volume of data and requirements for protection and availability. The volume of data generated by the re-centralization of data has created a demand for increasing numbers of disk drives. This has caused the inevitable increase in drive failures and complexities to manage. There are three primary issues that must be addressed to create a reliable storage environment. Issue 1. Today we fix what isn't broken. The problem? 59% of all drives customers reported as failing are actually found to have no trouble when sent back to the factory and are tested. This service event often leads to downtime and requires human intervention, introducing human error, the biggest source of data loss, and increases expense and risk, which could and should have been avoided. Issue 2. Drives are too small to serve as the foundational element for today's large storage environments. Merely increasing the number of drives, as done today, doesn't scale, but simply adds more serviceable components, more complexity, more management, and more parts that will fail. Issue 3. Current storage arrays are data flow bottlenecks due to having to manage caching, RAID, and disk hardware, host connectivity, and higher application functions such as virtualization. Intelligence in the controller constrains system scalability. In 2007, Xiotech acquired Seagate's Advanced Storage Architecture Group and the solution they had engineered known as ICE. Seagate's ASG engineers spent the past 5 years designing a smarter and better foundation to solve the foundational issues of individual disk. They created ICE, the new foundation of data storage. ICE's revolutionary design reduces disk failure while diagnosing potential issues and self-healing, eliminating drive replacements. Reliability is also increased by design characteristics to address heat and vibration, two limiting factors of disk life, increasing airflow channels to control heat, and minimizing vibration through patented technology. Each ICE houses 2 data packs, which can accommodate 3.5-inch drives, 10 per data pack, or 2.5-inch drives, 20 per data pack. If a drive is deemed unhealthy, the ICE performs a number of diagnostic and recovery actions and may do any one or any combination of the following self-healing processes. It begins by migrating data off of the disk to other drives. It resets the disk, power cycles the disk, remanufactures the disk, reformats and rewrites data tracks. The result? One or more heads may get retired, but remaining capacity and spindles are still available, all without human intervention. Should a disk fail, it is addressed at individual platter levels. ICE recovers smaller increments of data, such as portions of single surfaces, dramatically shortening recovery time, again without human intervention. ICE has many performance advantages over conventional technologies. ICE is 20 to 40 times larger than typical individual drives, requiring less area, moving parts, or, simply put, complexities to manage. Bottlenecks created by intelligence placed in the controllers have been opened by moving that intelligence into the ICE, allowing systems to scale both performance and capacity of increased data storage needs. ICE is 114 times more reliable than disk, drastically reducing your costs. ICE has 25% better performance than individual disk arrays, performing at a whopping 91,000 IOPS per ICE, and is easily scaled from 1 terabyte to 1 petabyte. ICE costs the same as disk, but has no support costs due to its reliability. This technology-enabled savings is passed on to you with our 5-year warranty. ICE is the new foundation of data storage for direct attached storage, network attached storage, or your storage area network.